Okay, let's dive straight into this explainer and tackle a deeply relatable real-world problem. Picture this. You're standing in the middle of a room you want to renovate. You've got a tape measure in your hand, you're staring at the floor, and suddenly it hits you. You have absolutely no idea how much carpet to order. Or, hey, maybe you're at the hardware store, completely paralyzed by the endless wall of paint, terrified of buying too little or, wasting a fortune on too much. Getting these projects right without a massive headache, it all comes down to one thing: truly understanding the space you're working with.
Since literally the dawn of civilization, human beings have been trying to tame and measure our environment. From ancient Egyptians mapping out agricultural plots along the Nile, to modern architects designing towering skyscrapers. To build or create anything in the physical world, we have to know exactly how to measure flat space. And geometry? Well, that's our ultimate tool for the job. Mathematical formulas are basically our secret weapons for translating the chaotic physical world around us into precise, actionable numbers.
Here's our quick roadmap for today. 1. What is a square's area? 2. The side-by-side formula. 3. The diagonal shortcut. 4. Step-by-step practice. And 5. Real-world square math.
All right, let's kick things off with section 1. What exactly is a square's area?
Honestly, a square is a geometer's best friend. It's one of the most fundamental two-dimensional shapes out there, totally defined by having 4 equal sides and 4 perfectly sharp right angles. Because every single side is the exact same length, it basically takes all the guesswork out of our calculations. No messy, unequal dimensions to juggle here. It's beautifully predictable, which, as you'll see, is going to make our math a whole lot easier moving forward.
So when we talk about finding the area, we're really just measuring how much flat space is trapped inside those 4 boundaries. A super easy way to think about this is to imagine you're trying to tile a bare floor with those perfectly uniformed little square tiles. Finding the area is just the mathematical way of counting exactly how many of those tiles will fit perfectly inside the room. This is exactly why area is always expressed in square units, like square meters, square centimeters, or square inches.
Now, people mix up area and perimeter all the time, but keeping them straight is absolutely crucial. Think of it like this. The perimeter is the physical wooden fence you'd build around the outside of a yard. It's literally just the outline. The area? That's the actual green grass growing inside the yard. If you're at the store buying fencing, sure, you calculate the perimeter. But if you're buying sod to plant a new lawn, you need the area. For this explainer, we don't care about the fence at all. We are strictly focused on measuring the grass.
Moving right along to section 2, the side-by-side formula.
Unlike a rectangle, where you kind of have to juggle different lengths and widths, a square is wonderfully low maintenance. Because all 4 sides are identical, we really only need one single measurement to unlock the whole shape. The formula is incredibly simple and elegant. Area simply equals the side multiplied by the side. Or, as you'll often see it written, side squared. That's it. Just one number gives you the key to the whole puzzle.
So, if you know just one side of a square, you can plug it into a super quick 3-step process. Step 1, identify that side length. Step 2, multiply that number by itself. And Step 3, tack on your square units so everyone knows exactly what scale you're working with. Let's actually take a moment to visualize how this works in practice. Imagine a large, perfectly square bedroom where one wall is exactly 5 meters long. Well, because it's a square, we automatically know the adjoining wall is 5 meters too. So, Step 1, our side is 5. Step 2, we multiply 5 by 5. Imagine physically laying down 5 rows of 5 1-by-1 meter tiles on that bedroom floor. You'd count out exactly 25 individual squares. Boom, 25 square meters. It really is that straightforward.
All right, on to section 3, the diagonal shortcut.
Let's be real. Sometimes the real world just doesn't give you all the information you want. What happens if you're measuring a space, but the outside edges are blocked by heavy furniture or walls, and you only know the distance straight across the middle, from corner to corner? That diagonal measurement might seem kind of useless at first glance. But don't panic. For this exact scenario, we use a slightly more advanced secret weapon formula. Area equals 1/2 times the diagonal squared. You might be wondering, wait, how on earth can we find the total area without knowing the outside walls? It works beautifully thanks to the Pythagorean theorem. Picture a square paper napkin sitting on a table. If you fold that napkin perfectly in half, from corner to corner, you draw a diagonal line that effectively slices the square right into 2 identical right-angled triangles. Because of the mathematical rules governing those triangles, we can completely bypass the outer edges and calculate the total space just from that one central fold line. Pretty cool, right?
Let's test this shortcut out and walk through some quick mental math. Say you measure a small square pane of glass, and the diagonal from corner to corner is exactly 10 centimeters. Step 1, we square that diagonal. 10 times 10 is 100. Step 2, we take that 100 and cut it exactly in half. Just like that, you've completely bypassed the outer edges and found your exact area, 50 square centimeters. It is such a handy trick to keep in your back pocket.
Let's put this to work in Section 4. Step-by-step practice.
When you sit down to tackle real practice problems or calculate materials for a project, the trick isn't just mindlessly memorizing formulas. The true skill is being a bit of a mathematical detective. You have to look at the clues you're given and know exactly which tool to grab. If they give you the outer wall, you use the side formula. If they give you the inner line, you grab the diagonal shortcut. Let's walk through the logic of a problem that's actively trying to trick you. They don't give you the side, and they don't give you the diagonal. Instead, they tell you the perimeter is 52 units. Remember our fence analogy? That 52 represents the entire outer boundary added up. But since we know a square has 4 identical sides, we just work backward. We divide that perimeter of 52 by 4. That one simple step reveals our hidden single side length, which is 13.
Now that we've uncovered our side length of 13, we're right back in familiar territory. We grab our trusty side-by-side formula, we square that 13, multiplying 13 by 13, and we boldly arrive at our final area of 169 square units. By taking a breath, working backward, and breaking it down step by step, even the trickiest problems just kind of fall right apart. Take a quick mental snapshot of this recap before we finish up. Area is always the flat space contained inside the shape. If your clues give you the side length, you simply square it. If your clues only give you the diagonal, you square it and then cut that number in half. These two methods ensure you are covered from literally any angle.
Finally, Section 5, Real-World Square Math.
This math isn't just for passing high school geometry tests, you guys. It genuinely powers the world around us. Think about an interior designer who needs to order custom flooring. By perfectly calculating the area, they avoid buying hundreds of dollars of excess material, minimizing waste and maximizing profit. Or consider a farmer plotting agricultural land. They need the exact square meterage to calculate precisely how much seed and fertilizer to distribute for maximum crop yields. Even in cutting-edge tech, hardware engineers use diagonal area shortcuts every single day to optimize pixel density on square smartwatch screens. These basic geometric formulas are absolutely vital across almost every industry.
With just these two simple formulas now securely in your toolkit, you have the power to measure, quantify, and build the physical space around you with absolute confidence. The world isn't just a chaotic collection of random shapes. It's an elegant mathematical puzzle just waiting to be decoded. You are now fully equipped to figure out the exact area of any square you encounter. So the only question left is, what piece of your world are you going to measure next?